All right, guys, welcome to the last part of linear systems. We're going to look at kind of a hybrid between 1.3 and 1.5, which is solving problems using linear systems. So the first thing that we're going to look at is deciding which method is best. So for each linear system below, choose which method you think is best and give a reason why. So for the first system that we have here, if we evaluate it, I see that one of the variables is isolated. In the second equation, y is already by itself. So I would take all this and substitute in place of y is probably easiest because I can do the substitution method right away. So I'll write that. I would say that graphing is probably not the easiest because I'm going to have to rearrange this top equation into y is equal to mx plus b, and then I'm going to have to make a grid and graph those out. I could do that, but it's probably not the easiest way. And elimination is probably not the easiest because I would have to rearrange my equation. I'll bring this 5x over here. Then I'd have to get the same coefficient in front of my variables. So for example, I see that I have 3 and 5 in front of my x's, 2 and 1 in front of my y, so I'm going to have to make an equivalent linear system in order to solve it. So not really the easiest, but substitution looks like it'd be the easiest in that case. For b, this linear system that we have here, think about which one you think would be easiest. So I would say in this case either substitution, because I can take y and substitute into y in the second equation, it's already isolated, or graphing if a grid's given to you because they're both in y is equal to mx plus b. I would say both would be good in this case. You might lean towards substitution a little bit because, as you know, when you use substitution, you're going to get exact answers. So like, for example, if we're graphing that and the two lines do not cross at a nice spot, might cross in between 1 and 2, it's difficult to tell by graphing what the exact value is, where a substitution can get exactly what the answer is going to be. And finally, the last one, which one would you choose for this system? Well, if I look at this one, substitution is not the easiest because it's not easy to isolate one of those variables. Right? I'm going to have x, x, y, y. None of them are easily isolated because none of them have a coefficient of 1. Because of that, graphing is also not the easiest. In this case, elimination would be the easiest. You see it's lined up in form of ax plus by is equal to c. They're both in that form. It's just a matter of multiplying the equations to get the same coefficient. So like, for example, if you remember elimination method, I would look at 3 and 2 and say, well, 6 is a common multiple, so I'm going to multiply the entire top by 3, multiply the entire bottom by 2, so that we get 6x, and then decide whether I'm going to add or subtract. Or if I wanted to eliminate y, I could look at 3 and 5 and say, well, 15 is a common multiple, multiply the entire top by 5, and multiply the entire bottom by 3 in order to get the same coefficient on y to eliminate it. So elimination. Next, how many possible solutions can you get when you solve a linear system? Now, for all the ones we've seen, we've all got x is equal to some number and y is equal to some number. Well, that's because when we graph, we have had one spot where we have an x and y coordinate. So we can simplify this question down and say, well, how many ways can lines intersect each other? Well, what would happen if we had two parallel lines? What would happen in a case like that? What would be the solution? Well, in a case like that, there would be no solution, because those lines never meet. There's no x and y coordinate. Whereas opposed to the one on the left, we'd have one solution. So there doesn't always have to be, or there won't always be an x and y coordinate that balances both equations. Sometimes, if I have the same two parallel lines, they're not going to intersect at all, and there is no solution to questions sometimes. There's one more possibility, if you can think of it. It's not going to be crossing twice. The other possibility is if I have one line and I have a second line right over top of that one. Well, that one would be an infinite number of solutions because it's the exact same line. So we would end up with x and y, lots of spots, right? There'd be one here. There'd be one here. There'd be one here. So lots of different solutions. So what I want to do is look at cases, what happens or what do you come to if you end up with that as your answer. So we know that there are three possibilities. Let's investigate. So what would happen if I had two parallel lines? So I'm going to choose, remember two parallel lines have the same slope, so maybe like x plus 5 and y is equal to x plus 3. Where if I was to graph these, well, they both have a slope of 1, but different y-intercepts. So one of them starts at 3, goes up, one of them starts at 5, and increases with a slope of 1. So those lines would be parallel. So what would happen if I use substitution on this? Well, you'd see right away, actually use a different color here. I'm going to take x plus 5 and substitute it in over here. We're going to get x plus 5 is equal to x plus 3. And when I isolate, I'm going to get x minus x is equal to 3 minus 5. And we end up with 0. X is gone. We took our x out of the equation, so I'm not even able to isolate for x in this case. So unable to solve. So that's what's going to happen. You're not going to be able to solve for x in a case like that where there's no solutions. And what happens in a case where there's an infinite amount of solutions? So we have the exact same line. So let's suppose we have y is equal to x plus 3, and the other is, y is equal to x plus 3, right? The exact same line. If I was to graph it, it would be one line on top of the other. This has an infinite amount of solutions. So what happens in that case? Well, I'm going to take x plus 3 and substitute it in over here. I would isolate. X minus x is equal to 3 minus 3. I would get 0 is equal to 0. So I'm unable to isolate for x. However, that final line, that's true. The one over here was not true. So this would be an infinite number of solutions. Because they are two lines, one right on top of the other. So if I think of where they meet, there's an infinite amount of x and y possibilities. So like, for example, if I was to think of this, suppose I had, x is equal to 0 and y is equal to 3. That would be one solution for that because it balances both equations. What about x is equal to 1 and y is equal to 4? That would also be a solution. Balances both equations. Right? Because just one linear equation has an infinite amount of x and y's. If we have the exact same linear system with two linear equations that are exactly the same, there's an infinite amount of solutions for that. So that's something to keep in mind as we work through. Most of the times you're not going to have to worry too much about it, but if you ever come to this situation, know that there are three possible solutions. You could have one answer, you could have no answer, or you can have an infinite amount of answers for x and y. So let's solve some problems here. So, word problems. You've seen some that are similar to this, so we're going to go through them relatively quickly because you get the idea. I just want to show you the different types of questions you could see. So the first one says our test has 20 multiple choice questions worth 100 points. The test consists of true and false questions worth 3 points each, and multiple choice questions which are 11 points each. How many multiple choice questions are on the test? So we have two unknowns. We have M, multiple choice questions. So that's the number of multiple choice questions. And then we have, maybe we'll use T for true or false questions. So we're going to have to break down some of our equations here. So the first thing that I read is a test has 20 questions. So that means all the multiple choice questions plus all the true or false questions, it's 20 of them. Right? That's just magnitude of questions. There might be one multiple choice and 19 true or false. There might be 2 multiple choice and 18 true or false. We don't know, but I know that there's 20 questions in total. Next, I know there's 100 points. So I know that all the multiple choice questions are worth 11 points each. So this is 11m, because 11 times m will be all the points awarded for multiple choice questions. Plus, the true or false questions are 3 each. So 3t is equal to 100 points. So keep in mind, these are all the points on the test awarded from multiple choice questions. 3 times t is all the points awarded for true or false questions. So for example, if there are 5 true or false questions, there are 15 points awarded for that. So then what we're going to do is we're going to solve this, choose a method that we think is best. Most likely you're looking at this and saying, well, substitution looks pretty easy to me. M is equal to 20 minus t. And I'm going to take that m is equal to 20 minus t and substitute it in for m over here. So that's going to leave me with 11 times 20 minus t plus 3t is equal to 100. And I'm going to try to solve that through. When I multiply inside, we're going to have 220 minus 11t plus 3t is equal to 100. Get all my like terms together, add them together. So when I bring 220 to the other side, plus 3t is equal to 100 minus 220. Add my like terms together. I have negative 8t is equal to negative 120. And then I divide both sides by negative 8. So 120 divided by, negative 120 divided by negative 8 is 15. So now I know there are 15 true or false questions on this test. And then I can go back up to find out, well, how many multiple choice there are. Well, we know m is equal to 20 minus t. Right, we have that written right here. So m is equal to 20 minus 15. M is equal to 5. So I know there are 15 true or false and 5 multiple choice questions. Therefore, there are 15 true false and 5 multiple choice questions on the test. Oops. And there we go. So just like ones that we've seen before, nothing out of the ordinary. Same with the next one that we see. You can see it's very similar to ones that we'd seen in the past. Next one talks about Stefan. He bought some eating utensils, so he's buying forks and spoons. It says he spent $33 on his eating utensils. Spoons cost $4 and forks cost $3. If he bought a total of 9 utensils, how many of each kind did he buy? So the equation is very similar to the one that we saw above. So S might be number of spoons bought. And F might be number of forks bought. Now I need to make an equation for it. I know we bought 9 utensils in total. So S plus F is equal to 9. Now I need to assign some money. So each S that he bought, each spoon that he bought, cost $4. So $4 times all the spoons that he bought, plus All the forks that he bought cost $3. So 3 times F would be the total amount that he spent on forks. And in total, he spent $33. So similar to the question above, the setup is almost the same. I'm just going to isolate for one of my variables, same idea we did before. S is equal to 9 minus F, and substitute 9 minus F in for the variable S. As we multiply through, negative 36, I know you know how to do this already. Bring over to the other side. I'm going to get negative 4F plus 3F is equal to 33 minus 36. Add my like terms together. Negative F is equal to negative 3. And divide both sides by negative 1. We get F is equal to 3. That means he bought 3 forks. And I put that back into the S equation that we isolated earlier. 9 minus F. S is equal to 9 minus 3. S is equal to 6. So he bought 6 spoons and 3 forks. And that's our final. So you see those two questions are relatively the same. The setup is almost the same. The equations looked similar, just the variables stood for different things. Next one, kind of did a question like this in the other video, but it talks about ordering from a restaurant. So a different order for a different price. So this one says 4 cheeseburgers and 3 orders of French fries cost $9.60. Not very expensive, actually. 2 cheeseburgers and 4 orders of fries cost $6.80. How much does an order of fries cost? So let's go through this. Our unknowns are how much it costs for 1 cheeseburger and how much it costs for 1 fries. Cost. So I'm going to call C, cost for cheeseburger. And I'm going to call F, cost for fries. Now, each situation will be its own equation in this one. So we don't have a sum total like he bought 9 forks. There were 10 questions or 20 questions on the test. This one says 4 cheeseburgers. So you paid C 4 times. 3 French fries. You paid F 3 times. And it cost $9.60. For the next time you went, you paid C twice, so 2C. And you paid 4, or F 4 times, is equal to $6.80. Now this is a case where we want to solve. In this case, it specifically asks us for order for fries, so it's specifically asking for F. Actually doesn't care about C, but we're going to solve it just like before. We're going to look at this one and say, what method do you think is easiest in this case? So you might look at this one and say, well, I think that elimination is best because I have coefficients in front of each of my variables. 4, 2, 3, 4. It's not easy to isolate one of my variables, so I'm going to use elimination. So I'm going to create an equivalent linear system beside it. So if I'm going to eliminate whichever variable, in this case, I'm going to choose C because I know that I can take the bottom equation and multiply it by 2. So I'm going to take this one, multiply it by 2. This one, I'm going to keep it the same, multiply by 1. So I'm going to have 4C plus 3F is equal to $9.60. The one on the bottom, 4C plus 8F is equal to $13.60. Now, I need to decide, should I add or subtract these ones together in order to eliminate C? In this case, I'm going to subtract because 4 take away 4 is 0. I want 0. So I get 0C. And I'm going to subtract next. 3 take away 8 is negative 5F. And 960 take away 1360 is negative 4. From there, we're going to divide or deal with our new equation because this one's been eliminated, 0C. I'm going to divide both sides by negative 5. We're going to get F is equal to 0.80. That means an order of fries costs 80 cents. And that's the end of the question because the question just asked us for how much does an order of fries cost. But let's find out C just for the sake of finding it out. So I'm going to take F and put it back into one of the two equations. Doesn't matter which one. I'll take the top one just because it's the top equation. 4C plus 3F. Well, I know F is 80 cents now. Is equal to 960. 4C. I need to figure out what is the cost for 3 French fries. So I'm going to multiply 3 times 80 cents in my calculator. And we get $2.40 or 2.4. Now I have 4C is equal to, I'm going to subtract 2.4 from 960. I get 4C is equal to 720. And I'm going to divide $7.20 or 7.2 divided by 4. And I get C is equal to $1.80. So very similar to the ones above. Solving it through, it's a word problem. I just need to write my sentence now. Therefore, a cheeseburger costs $1.80. I wish it cost that much. It's a lot more expensive. And fries cost 80 cents. And that's that one. We saw one like that in an earlier video as well, the elimination video on 1.4. Now we have one last type of word problem that I want to introduce. This is the first time we're going to see ones like this, but something that we can handle. So I'll do my best to break this one down. This one says a scientist needs to create, or needs to create or to have, maybe it should say create or have, a 10 milliliter acid mixture that has 2% acid concentration. So usually acid is not 100% acid, right? It'll be acid and there'll be water in it. So I'm saying, so I guess it'll be 98% acid or water and 2% acid, and it's all mixed together in there. So they need to have a mixture that has 2% acid concentration in it. When she looks in the supply cabinet, she finds that there are only 2 types of acid. One that has 1% acid concentration and the other has 3.5% concentration. So you can imagine, here's the jug, has 1%. This one over here has 3.8, 3.5%. And we need to make a new mixture. So we want to know of these, I want to have 2%. So how much should I pour from each to get that? Right? If I pour it all from the one on the left, I'm just going to have a mixture of 1%. If I pour it from all the one on the right, I'm just going to have a mixture of 3.5%. So I need to dilute it a bit, mix the two together to figure out how much of each. So I know that this one's going to have 10 milliliters. So what combination should I pour from each of them to get that? So let's write our variables. Maybe I'll say A will be milliliters of the 1% mixture or concentration. And maybe B will be milliliters of the 3.5% acid. Right, how many should I use from here? And how many should I use from here? This is A milliliters. This will be B milliliters. And we want to have a 10 milliliter mixture that has 2%. So let's make this equation. First things first, I know that we're going to have 10 milliliters of liquid in our mixture. So I know I need to pour out 10 milliliters. So I know that A plus B, so the milliliters of each, needs to equal 10. That's the first one. Next one, we need to talk about the amount of acid that's being poured out. So from A, I know it's 1%. So 0.01 A, that's 1%. Plus 3.5% is acid in the other one. So 0.035 B is equal to, I want my mixture to be a 2% mixture. Times 10. Because each one in that equation is written out the same. It's the percent of acid times how many milliliters. The percent of acid times how many milliliters. The percent of acid times how many milliliters. Basically, what each of these terms represents is the milliliters of actual acid. So for example, this one on the end over here, I can multiply that. That would be just be 0.2. So what does that represent? Well, that means 0.2 milliliters will actually be acid because that's 2% of 10. So that's kind of where we are with this one. So that second equation is a little more difficult in this case. That happens when we're mixing two items together. So we're going to decide which method do we think is best to use here. Now, an argument can be made for substitution and for elimination. Whichever you're comfortable with, use. You're going to get the same answer anyway. In this case, I'm going to use substitution because I see I can isolate A or B from the top equation pretty easily. A is equal to 10 minus B. And then I'm going to substitute 10 minus B in for A. So the numbers will get a little messy here, but you'll see that it will all work out. We get 0.01 A, which is 10 minus B, plus 0.035 B is equal to 0.02 times 10, or just 0.2, because I can multiply those. Now I'm going to distribute inside this first bracket. When I do that, I'm going to get 0.1 minus 0.01b plus 0.035b is equal to 0.2. I'm going to get all my like terms together now. Negative 0.01b plus negative 0.035b is equal to 0.2, and it's being joined by that negative 0.1 on the left, right? This one just came over to that side. Now I can add my like terms together. We're going to get 0.025b is equal to 0.1. And then from there, I need to divide both sides by 0.025. So 0.1 divided by 0.025, and we get B is equal to 4. So that means we need to use 4 milliliters from B, which is the milliliters from the 3.5 container. And then I find the other one, the original equation, A is equal to 10 minus B, right? That's that box that we have in the top right-hand corner. And I know B is 4, which is going to leave me with an A value of 6. So we solved it. I know how much of each to use. Therefore, she should use 6 milliliters from the 1% concentration of acid and 4 milliliters from the 3.5% acid concentration. And that's it. So those mixture ones are a little difficult. There's a couple that are in the homework questions for you to practice, but they all kind of look the same, right? It's just a matter of understanding that second equation. How do we build that second equation? Percent times milliliters plus percent times milliliters equal to percent times milliliters. Where the one on the right is the mixture, and each of those terms is one of the containers. And we're adding them together. So that's it for linear systems. We have our word problems. We have our three methods that we can use to solve them. And earlier we kind of talked about which method is best. Whichever one you like best, you can use. And also the number of answers that you could potentially have. Now, normally we're just going to have one, but a situation may arise where you're going to have no solutions if it's two lines that never meet, the same two parallel lines. So that's that. If you have any questions, be sure to let me know.